Alright, hi Miss Glynn. This is Tyler and Jack's presentation on supersaturated solutions. Alright, here we go. Introduction. So, as you know, our original idea was to test out the reaction between various types of vinegar and baking soda. These three types of vinegar were regular white vinegar, red wine vinegar, and apple cider vinegar, as you can see down here on the left. And here they are cooking on the hot plate. And we wanted to investigate which one of these vinegars would react and eventually become a supersaturated solution. Going into this experiment, we believed that the only one that would become a supersaturated solution was the white regular vinegar. Alright, and then after experimenting in class, this was a complete failure. They didn't even go into a solid form, and we decided to scratch the original idea and create a new one. And the new one is as follows. So our final problem that we investigated was to make supersaturated solutions and see if they crash out with various solvents. Our solute here was sodium acetate, and our solvents were distilled water, tap water, and water with NaCl, sodium chloride.
So what is a supersaturated solution? A supersaturated solution is a solution that is completely dissolved in a liquid, even though there's more solute than the saturation point typically allows. And to make a supersaturated solution, one must heat up the solution to the saturation point of the fixed amount of the solute. Then the solute must be cooled back down slowly to the original temperature, undisturbed, so it doesn't crash out. The materials used to complete the lab were sodium acetate, a 125 milliliter Erlenmeyer flask, stirring rods, a measuring equipment, which includes a balance and a weighing boat, a metal scooper, NaCl, water distilled and tapped, a hot plate and hot plate grabbers, a refrigerator or any cooling device, and a thermometer.
Alright, so now we're going to go into our procedure, of which is obviously new for the refined lab, as we had a different procedure for our previous one. Alright, so obtain 3 125 milliliter Erlenmeyer flasks. Label each flask appropriately so that they don't get mixed up. One as distilled, one as tap, and one as salt water. Mass out 22.5 grams of sodium acetate and pour it into each flask. In the first flask, pour in 25 milliliters of distilled water. And mix it, shake around the beaker so that it dissolves, the flask. Repeat the step 4 with the second flask, so pour 25 milliliters of tap water this time into the second flask. And then in a separate beaker away from the flasks, pour in 25 milliliters of distilled water and mass out 9.75 grams of NaCl and pour that into the beaker with water. Stir it around until the NaCl completely dissolves in the water, which it will be unsaturated. And then pour that solution into the third flask. And then, alright, so now you have your 3 flasks with different solutions.
And we used 22.5 grams of sodium acetate in the 3 beakers because that's how you reach the saturation point in 25 milliliters of water at 30 degrees temperature, which is what we are reaching to make the supersaturated solution, and 9.75 grams of NaCl because that is how you reach the saturation point at 30 degrees for
Celsius.
Soda. Yeah.
Alright, so we'll continue our procedure here. Place all 3 solutions on the hot plate and heat them up to at least 35 degrees Celsius.
That's because you heat it at 35 degrees Celsius because that'll make all 3 solutions dissolve, and then you cool it back down to room temperature.
Yeah, so this is how we made the supersaturated solution. So when they are completely heated up, cool them back down slowly to 23 degrees Celsius, which is obviously below room temperature, so it will require an ice bath or time in the refrigerator for about an hour. We had the time, so we put it in the refrigerator and then came back a couple periods later and completed the lab. So now our solutions are saturated, or supersaturated, And to crash the supersaturated solution, there are various ways, but you could either shake the flasks, scrape them with a stirring rod, or add a few sodium acetate crystals. So pretty much you want to just disturb the solution.
Alright, observations. In the flask with the salt water, almost the entire solution crashed and crystals formed in the flask. The flask was warm, so we know that's an exothermic reaction. In the distilled water solution, a decent amount crashed. There were clearly crystals that formed and the flask was warm to the touch. And in the third flask, the top water flask crashed the least. No large crystals were evident, but there were clear traces of smaller crashes.
All right, we have some pictures here of our observations. So in the middle, you could see this one's labeled SW for salt water. You can see there's clear crashing going on down there.
And the top, the bigger crystals are sodium acetate, and at the bottom, which you can't see right now, are the salt water
Crystals.
Yeah, the salt crystals.
So it actually both crashed to, and that was the largest one. The second largest one was the distilled water over here. You could kind of see from this picture that there are some crystals formed down there, and so that clearly crashed out, but not fully. None of them crashed out fully, and the filtered water crashed out the least. You could see pretty much all the water. There's barely any crystals down there. So there's not really that. You could see traces, but it's not clear crashing. All right. Conclusion. So despite a rough start to our project and a bad first experiment, we quickly recovered and created a new experiment that went great. Our new experiment was very successful as we got the results that we wanted, and as all three crashed and we were able to make the supersaturated solutions, which was awesome. And we were very intrigued by the crash out demo in class, which is why we wanted to expand from it and do this experiment. And for this reason, we tested supersaturated solutions with the three various solvents, as we explained. And we discovered that sodium acetate can crash out with various solvents, not just distilled water, which we didn't really know going into this, which is why we wanted to test it out. We knew it would crash with distilled water, which it did, but it crashed even further with NaCl in the water, so that was interesting to us. And these were the results that we were hoping to find.
So, sources of error. The first reason why the tap water did not fully crash may have been that we took the flask with tap water off the hot plate too soon before all the solute dissolved. Therefore, it was never a supersaturated solution in the first place, and it was simply saturated with solute at the bottom of the flask. If not supersaturated, the solution could not possibly have crashed.
All right, we have two sources of error here, so Jax can go into the second one.
And the second source of error is what? Is that we may have accidentally added too much sodium acetate to the flask. There are many errors that could account for this, such as not zeroing out the weighing boat. If this occurred, the solute would not have fully dissolved at the given temperature that we heated it to, and again, it would be saturated rather than unsaturated and would not crash.
Correct. All right, follow-up experiment. So, as a follow-up to our experiment, there are a few more tests that we are interested in doing to find out even more results with the supersaturated solutions, as we are very intrigued with these experiments. So one of these is to test out other solutes, such as we picked a few here, potassium chloride or even sodium chloride in the three solvents, and the same procedure would be followed to make the supersaturated solutions, heating them up, cooling them back down, and then crashing them.
And another idea to continue the experiment would be to add sodium acetate to different solvents, such as club soda.
Rather than just the three that we used. So.
And we were going to see what happens when you add it to a solution with a gas in it.
Yeah, that was a little far out there, but we wanted to see maybe if we could do that. All right, and that's it. So, all right, thanks.